Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on oil network modeling using gap software. So now we will solve the network with the condition that wells are fully open. Okay, our 6 wells are fully open. And to do this, we will go to solve network here, run network solver, and then let's set the separator pressure of 200 psig. By the way, you can also try 10 pressures for sensitivity analysis. But now let's just try one separator pressure value, which is 200 psig. Okay, so now let's go to next and no optimization. Click on calculate. It's very quick. You see gap detected 1 hydraulic systems, loading MBAL for reservoir A and reservoir B. And that's it. The CPU time is 0.5 seconds, done. It's good news. And also, please note that as no controls have been set up, zero wellhead pressure drop will be applied in our case, which means that we have no choke in our wells. There are no chokes in our wells, and thus, the wells are fully open. If controls are set in the model, and the model is run with no optimization, then the gap will use a fixed value for the controls. A fixed value of 0 psi also means that the wells are fully open. The value used for the controls can be found under Edit, or like this. Maybe I can go back to Main, Edit, here, and then let's find Edit Equipment Controls. Okay, and then here under this actual column, we will have the value for the control here. Okay, once again, let's check the solve network. Next. So the computation done. So by the way, it is the case for fully open and no optimization is applied. Fully open, it means that the well doesn't have choke. We can also check the well. If we go to control here, DP control none. Okay, so it means that we don't have choke or the delta pressure drop of 0 or, no control at all. It means that, yeah, the wells are fully open. So click on OK here, solve network, run network solver, next, calculate again, done. All right, now to check the results of the solve network calculation, we have 3 methods. The first one, click on main, just fly over on our separator. You see here. So you can see that we can produce total liquid production rate of 23,621 stock time barrel per day, with the oil of 21,659 stock time barrel per day. So that's the first method, just fly over on our separator, or fly over on any element that you want, placing the pointer on each element in the network model. We can also double click on each element, like in this case, separator, and then let's just click on results. You see here. So we get liquid rate here, 23,600, oil rate, 21,600. Okay, good. And this is gas rate, water rate, and so on and so forth. And that's the second method. So the first method is fly over. The second method is double click, enter the results. And lastly, the third method, we go to results, yeah. And then we can also go to detailed. You can also check all items, all wells, all inflows or summary or total system. Okay, let's just check total system. So you get that this is the pressure, oil rate, gas rate, liquid rate, the same thing. Okay, you can also plot like this, liquid rate, because we only have, one pressure value, so it's like this. It is what it is. Okay, you can also check results, detailed, all items like this. All right, so that's it. So that's the first question to answer, which is about the deliverability of our network. If the wells are fully open, then how much oil we can get, how much liquid we will produce. And this is the answer. If all wells are fully open at 200 psig network pressure, then we can get liquid rate of 23,000. Maybe we can go back to here, 23,600, and the oil 21,600. That's it. And in the next video, we will try to answer the second question, the second big question, which is that if we choke back our wells and we have constraint of total liquid production of, say, 20,000 stock tank barrel per day, then how to optimize the network? Okay, by reaching the constraint while at the same time optimizing the oil production. But we will answer that in the next videos. Until then, see you and thank you.